The absolute maximum of the function f of x equals x squared minus x minus 2 on the interval 0 to 3 is what? Right, the biggest mistake on the exam on this one is you wanted to give an x value instead of a y value. An absolute maximum is a y value, and it's the highest y value the function reaches on an interval. The first thing that we want to do is find the critical number, so I'm going to take the derivative, which will be 2x minus 1. I'm going to set the derivative equal to 0 to get some critical numbers. And notice when we do that, we'll get x equals 1/2. Okay, this time, since we're looking for absolute instead of relative, we actually are going to plug the critical numbers and the endpoints back into the original function. So we're going to find f of 0, f of 3, and f of 1/2. And again, we're going to plug these into the original function. So if I plug 0 into the original function, I get -2. If I plug 3 into the original function, I get 4. And if I plug 1/2 into the original function, I'll get -2.25. Okay, so from here, my absolute maximum is the absolute biggest y value the function reaches. So my absolute maximum is going to equal 4. Number 27, find the limit analytically, which means algebraically. So the first thing we want to do is, if we want to find the limit as x approaches 2, is just to try to plug in 2 and see if we can get an answer. So if I plug in 2, I'm going to get 4 minus 6 plus 2 over 4 minus 4. That gives me 0 over 0. That doesn't mean we don't have a limit. I just can't do it that way. So the next thing I'm going to do is try to use the cancellation technique. So I'm going to factor the numerator. I'm going to get x minus 2 times x minus 1. And in the denominator, that is a difference of squares, which is 2 minus x, 2 plus x. Now, this is the biggest mistake people made on the exam, is that we have to notice that I can almost cancel the x minus 2 and the 2 minus x if I factor out a -1 from one of the problems. So I'm going to factor it out with the 1 in the numerator. So if I factor out a negative from x minus 2, it will become 2 minus x. Everything else in the entire problem will remain the same. And then if I do that, now I can cancel the 2 minus x's, so I'm left with negative x minus 1 over 2 plus x, and my whole goal is to now be able to find the limit as x approaches 2. So now I'm going to put a 2 wherever there's an x, so negative 2 minus 1 over 2 plus 2. That will give me -1 over 4, and that will be my limit. Number 28, let f of x equal the square root of x minus 4. Find the derivative of the inverse at 2. The biggest mistake on this one was just knowing that formula to use. We're going to use 1 over f prime of f inverse of 2. And there's lots of steps with this problem, and people just tended to leave out some of the steps. Okay, the first thing that we want to find is the inverse at 2. And remember, if the 2 is the x on the inverse function, it is the y on the original function. So we're going to go to the original function and plug 2 in for the y. Okay, if I solve this for x, I'm going to square both sides. So I'll get 4 equals x minus 4. And if I add 4 to both sides, I'll get x equals 8. So we now have just found that this part right here is 8. So my next step is to find 1 over f prime of 8. So now I need to find the derivative at 8. So I'm going to come over here. My function is the square root of x minus 4. I'm going to rewrite that as x minus 4 to the 1/2. I'm actually going to do a u substitution since I've got parentheses. U will equal x minus 4. Du will equal 1. So if I rewrite that as u to the 1/2, when I go to take the derivative of this, it will be 1/2 u to the -1/2 times the du, which is 1. Now if I just rewrite this, I'll get 1 over 2 square root of the u, which is x minus 4. Now what I wanted to find was f prime of 8. So if I plug 8 into this problem now, 8 minus 4 is 4. The square root of 4 is 2. 2 times 2 is 4. So my derivative at 8 is 1/4. So now I know that that answer is 1/4. So 1 divided by 1/4 will equal 4, and that is the derivative of the inverse. Okay, 29. For what values of x is the function y equals -x cubed plus 12x squared minus 1 decreasing? And we will have to justify our answer on this one. Okay, if a function is decreasing, then we will know its derivative will be negative. So we definitely want to find a critical number and make an f prime chart. So, and actually in this one, instead of f prime being negative, since the function is called y instead, y prime will be negative. So y prime will equal -3x squared plus 24x, and that will do it. Now let's set the derivative equal to 0. And I'm going to factor out a -3x, and when I do that, I'm going to get x minus 8 still equals 0. So my critical numbers will be x equals 0 and x equals 8, which means I'm now going to do not an f prime chart, but a y prime chart. Put 0 and 8 on there. If I put negative 1 into the derivative, I will get a negative answer. If I put 1 into the derivative, I'll get a positive answer. And if I put 9 into the derivative, I'll get a negative answer. So when it says where is the function decreasing, that would be wherever the derivative is negative, which would be from negative infinity to 0 and 8 to infinity. And that would be because y prime is negative. Okay, number 30. Find the equation of the tangent line to the graph of f of x equals 3x cubed plus 2x squared minus 5 at the point 1, 4. So when we're done, we're going to have an equation that looks like y equals mx plus b. So the first thing we want to do is find that slope, which in this case will be the derivative. So the f prime will equal 9x squared plus 4x. Okay, biggest mistake that I saw people make on this one is that you wanted to set it equal to 0. We're not finding critical numbers on this problem. We're just trying to find the slope at this point. So to find the slope at that point, all we need to do is plug in 1 for our x. And so my slope will equal 13. So that is my m. And now we're ready. This is my x, this is my y. We can find the equation of the line. So we'll have 4 equals 13 times the x plus b. So I'll get 4 equals 13 plus b. B will equal negative 9. So the equation of my tangent line will be y equals 13x minus 9. We could have made our lives a little simpler by using point slope form, which would have been y minus 4 equals the slope x minus 1. So either one of those answers is totally correct. Okay, number 31, discuss the continuity of f of x equals x squared plus x minus 6 over x squared minus 9 and be detailed. What we're going to be focusing on here are wholes and vertical asymptotes. So what I'd like to do first is go ahead and factor that. That will factor as x plus 3 times x minus 2 over x plus 3, x minus 3. Okay, I notice the x plus 3's will cancel, so that's going to create a non-removable discontinuity, which will result in a hole. So I can say there is a hole at x equals negative 3, and there is a hole because of a removable discontinuity. Okay, and then I notice the x minus 3 does not cancel, which means there's going to be a non-removable discontinuity, which will result in a vertical asymptote. So now I'm going to say there is a vertical asymptote at x equals 3, and that's because of a non-removable discontinuity. Okay, and notice we didn't do anything with the x minus 2. If we were, please notice that would make the numerator equal to 0. So x equals 2 would actually be a 0 of this function.